Hello, everyone. In this video, we will introduce binary search trees in chapter 25. Binary search tree is a very efficient data structure for performing search, insertion, and deletion. In a list, if you want to search an element, in the worst case, it is order of n. Insertion, anywhere in the list, takes order of n time in the worst case, same as deletion. Binary search tree gives you order of log n time for search, insertion, and deletion. Let's see how this is done in the binary search tree. First, we introduce what is a binary search tree. A binary search tree is a binary tree with a search property. This is a binary tree, has a root, has the branches. Every node has at most 2 branches, left and right branches. These are the nodes called leaf nodes. Now let's look at this search tree. The binary search tree is that for every node, its left subtree is less than or equal to this node, and the right subtree is greater than this node. So here, this node is 60, 55. Everything on the left of 55 is less than or equal to 55. Everything on the right is greater than 55. So this is the search property. You can use this property to search elements efficiently. For example, if I want to search for 57, starting from the root, 57 is less than 60. Come to the left, 57 is greater than 55. Going to the right, now you find it, 57. Let's search for 61. 61 is greater than 60, goes to right. Less than 100 goes to the left. Less than 67 goes to the left, but there's nothing in the left. So 61 is not in the binary search tree. To represent a binary search tree, we use the nodes. Inside a node, we have this object, the element, and then 2 branches using this, the data field as a node point to the left or right node. So this is the class that defines a tree node. The element, left and right. So left and right, they're all tree node. And this is the tree node. You're going to create the tree node using this constructor. Let's see how we perform the search. Before we do this, I like you to look at this animation. So this is binary search tree animation. Let's add 57 into the tree. So how do you add 57? You're going to first perform a search. 57. 57 is greater than 50, less than 80. So you're going to put 57 right here. So this is inserted. All right, let's do a number here is 45. 45 is less than 50, greater than 25, and greater than 35. So 45 is going to be put right here. So this is how you're going to insert it. You perform a search and locate it. Now, we're going to assume that for simplicity, all these elements in the tree are unique. So if you want to insert 45 again, so you're going to get the message that says that 45 is already in the tree. Going back to this, how do you perform a search? You can write this code, search the element in the tree, starting from the root. Here is the current. Why current not equal to null, we're going to look comparing the element with the current dot element. So if it's less and it goes to left, if it's a greater, it goes to right, else it's going to be located as a match, so return true. When this loop ends, current is null, that means you did not find anything, so return false. Inserting an element, you are going to writing this algorithm. So starting from the root, you're going to create this new element. Well, if the root is null, so you're going to create this element. Else, you're going to perform a search. So this is very much like the previous search algorithm. And so this, except that when you have this, is this one here is we're going to search why current is not null. We continue, go to left and right. And now if there's a match, we're going to return false because we assume all the elements are unique. So you're not going to insert anything. So this is return false, means there's duplicate node. All right, else, so when you are doing this search, you have this parent and a current. So the parent is going to be where you are going to insert a node under the parent. So this is going to see this is the current, and we're going to start this, the parent and current. Look at the relationship. So, and going down here, and you can see this, this is the parent, this is current. So we're going to suppose you insert 101 into the foreign tree. So 101 is greater than 60, goes here. So here's the parent, and this is the current. And now, and going down, you're going to see this is the parent and current, and right here. And now continue, and you're going to see, and this is parent, and the current is null. So this is when you're going to put it on the left side of 101. So here, look at the element is less than parent's element. And you create the node and put it on the right side of the parent. All right, so now the common operation for trees is the tree traversal. Tree traversal is the process of visiting each node in the tree exactly once. There are several ways to traverse a tree. this section presents in order, pre-order, post-order, depth first, and breadth first search. In order traversal is to visit the left subtree of the current node first recursively, and then the current node itself, and finally the right subtree of the current node. The post-order traversal is to visit the left subtree of the current node first, and then the right subtree of the current node, and finally the current node itself. So this is recursive traversal. So I'm going to look at this also. There's a pre-order. Pre-order is visit the current node first, then the left subtree of the current node recursively, and finally the right subtree of the current node recursively. Let's look at this example here. Let's go down to this, look at the animation here. So we have this animation. So look at the animation here. So let's do in order. In order, so you do this recursively left, and then the current one, and then this recursively right. So this is going to be 25, 35, 50, and 80 for the in order. So that's the in order. See, when you perform the in order search on this left subtree recursively, so you are going to use this again recursively and go to the left, there's nothing, and then this is 25 and 35. All right, so this is the pre-order, and pre-order, you're going to go with the this 50, this is the node, and then the left and right. So that's the pre-order, starts with 50. All right, so please also study the example, see the post-order. And so this is, go to the tree traversal and see the what is the breadth first traversal. And the breadth first traversal is to visit the nodes level by level. First, visit the root, then all the children of the root from left to right, and the grandchildren of the root from left to right, and so on. So this is called the breadth first traversal. It's level by level. All right, that's all for this video. In the next video, we will introduce the implementation of the binary search tree. We're going to provide the operations, and we're going to store data and how to manipulate the data in the binary search tree. Thank you for watching this video. See you on the next video.